Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Now, I would like to present Subject Network and Management Information System, code SKJ 3443. The title of this presentation is Network Topology. How does your network layout affect performance? Okay, our lecturer name is Professor Madya, Professional Engineer, Dr. Muhammad Farid bin Abdul Khair. Okay, I would like to introduce my group members. Me, Amira Shuhada Miti Ramli, 1181636. Then Mahira Binti Hashim, 1181613. Nor Shamimi Binti Roslan, 1181627. We are from MQC1. Number 1. Intro to the issue. It is not as easy to build and mount a network as to put pieces of network hardware anywhere you need them. You need to carefully map out where an appropriate network will be designed for each network node. Your network's physical architecture or your network topology needs to provide your entire business infrastructure with operation. It also needs to account for all the devices you need to connect to your network and be built around them. For the initial network preparation stage, however, planning a network topology is not only necessary. Enterprise networks are increasing, and alongside them, their topology will expand. A network's physical configuration also impacts the efficiency of the network. Read on to find out how your network's physical topology will impact how your network works and behaves. Number 2. Why us choose the issue? The layout of your network is important for several reasons. It plays an important role, above all, in how well your network operates. Choosing the right topology for the operating model of your business will improve performance while making it easier to find faults, troubleshoot failures, and distribute resources across the network more efficiently to ensure maximum network health. A streamlined and properly managed network topology can increase energy and data efficiency, which can in turn help to reduce operational and maintenance costs. In a software-created network topology diagram, the configuration and layout of a network are generally seen and manipulated. For a few reasons, these diagrams are important, but particularly for how they can provide visual representations of both physical and logical layers, enabling administrators, when troubleshooting, to see the connections between devices. Okay, the third one is objective of the report. At the end of this report, we should be able to achieve all the three objectives below. First one, be able to know all types of network topologies very well. Second one, differentiate correctly between all types of network topologies. The third one, manage to choose what kind of network topology that suit well to the network performance.
Hello everyone, so my name is Mahira Binti Hashim. My matric number is 1181613. So let's go to the finding on the issue of this topic. So what we got here is, firstly, is the definition of network topology. So network topology refers to how various nodes, devices, and connections on your network are physically or logically arranged in relation to each other. So it refers to the structure of the network and how communication is made between the computers. So there is 4 types of network topologies, which is the important types. Here is bus, ring, star, and mesh topologies. So bus topology connects every device on the network to a single cable that runs along the entire infrastructures. So this cable provides a central point of access. So the central cable weakness may be a dead sentence for the entire network. Then ring topology. A ring topology connects network devices to each other in a line that turns into a closed loop. It can be unidirectional or bidirectional. Then is star topology. A star topology features a central hub or switch that all network nodes and devices are connected to. So most commonly seen in modern network implementation. Most star configuration use copper wire twisted pair cable, but some high-speed version use fiber optic cable. Then is a mesh topology. A mesh topology is a setup where network devices make multiple connections to other network nodes. So one network node, such as a switch, rather than just one, can establish different connections to multiple nodes in range. So mesh is rarely used as a LAN topology, but is often used to create a WAN topology. So that's for the types of network topologies. Next, we go to the insight about the findings. So the observation that I got from the findings that I got. So, firstly, we have to deeply familiar with the needs and usage requirements of our network, which is we have to analyze first and observe first what actually that we need for our network. So then we can choose the best topology. So the total number of nodes on the network is one of the primary considerations to account for, as this will dictate whether it's feasible to use a simpler topology or whether you will have to make the investment in a more complicated network structure. So there is no topology is called the best because each offers its own set of perks and drawbacks depending on the network environment we are working with or attempting to set up. That means here that there is between the 4 topology that I have mentioned, there's no best topology, which is I can conclude which is the best topology. This is for you, is the best for you, cannot, because the best topology for you is what that your network need. So you have to observe first what your network or need, and then you will choose the best topology that you can based on the need of your network. That's all from me. Thank you.
Assalamualaikum, I'm Shamimah MQC1, lecture number 11816. So, as we know that every problem has a solution, same goes to this problem on how to increase network performance through the physical layout of network. So, in this section, shows the suggestion that we analyze from the information we get. First and foremost, we must know the principle of network design to get it right for effective network design. As we have said before, the network design could affect network performance. The best suggestion is to figure out on how network architecture affect a network's efficiency. Then, we can begin to create a perfect network in a company or enterprise. Some of the network design principles that affect the efficiency of networks include: first, estimating traffic load; second, network mapping; and third, network node placement and service coverage. First, estimating traffic load. First, the network would need to achieve a basic level of efficiency depending on the needs of this enterprise. Specifically, across all areas of network, the network needs to maintain a normal degree of traffic flow. For example, to understand the network requirements, the network team needs to know how much data your business uses on a regular basis. The second one is network mapping. If our network staff does not imagine our network, it will be difficult for them to identify and fix any issue that occur. It is an incredibly useful step in effective network design to create a visual map of our network, either manually or via a network performance monitor (NPM) with mapping capabilities. Last one is network node placement and service coverage. At the very least, networks have to cover the entire enterprise campus. To encourage this, your network team can position nodes in positions that produce the largest coverage area while keeping down the use of your resource. So, overall, it may be said that the network design basics need to be taken seriously as to avoid big problems happen in the future. So, for the conclusion, to conclude, it is true that physical layout of network could impact on network performance. There would be pros and cons in each physical layout that we apply based on the company layout. We must concern about the company layout and the network design basic as to build a perfect network and also help us to understand the principle of networking more better. Thus, the key to create and configure the right model for networking is subjective. For any enterprise, before implementing any particular network topology, it is very important to first collect all the requirements and needs. So, thank you for watching.